Welcome back, all my good humans. You may have some coins laying around your house, and one day you decide to count just the quarters, because obviously the quarters have a bigger value than the others. And with that being said, you end up with 100 quarters. And then you said to yourself, let's see how many variety of sets can I get from this 100 quarters. So you started counting and putting them in sets. You'll notice that you end up with 2 sets of 50. And then when you go back again, you end up with 4 sets of 25. And then the other set is going to be 5 sets of 20. You might say to yourself, how can I apply this to algebra? Yes, you can. You can apply this to the concept of factoring quadratic expression. And when you are factoring quadratic expression, you are usually given a quadratic expression in one of 3 forms. It is usually in the basic form of ax squared plus bx plus c. And then, in essence, you have to factor this out so that you will get 2 sets of binomials. That is what we call the 2 sets of the coins that you were rattling with and trying to put them into a variety of sets. Not all the time you will end up with the standard form, which is ax squared plus bx plus c. The quadratic expression that will be given to you sometimes will be in the form of ax squared minus bx plus c. Another example could be ax squared minus bx minus c, or it could be ax squared plus bx minus c. These are the 4 format of quadratic expressions that will be given to you, and you will be asked to factor them. And in doing so, you will end up with 2 sets of binomials. You always end up with 2 sets of binomials. And then these numbers in each of the set is going to be a number which is going to derive from the last term. Let's get right into this, and I'll show you the 4 basic examples. Let's start out with first one, x squared plus 9x plus 18. I must say to you first that in this case, I am only going to factor the quadratic expression when a is equal to 1. Only for a is equal to 1 in this case. A is equals to 1. So the steps are, you are going to take the last term, which is a c, find the factors of the last term such that when added is going to give you your middle term, which is 9. Notice here that your last term is a positive number and your middle term is also positive. Hence, your factors are going to be positive. So we have 18, and we're going to find the factors of 18 such that when we add them, it's going to give you that middle term. So we will start off with 1 and 18. When we add that, we will get 19. We're not looking for 19. We are looking for 9 here. So we cannot use that. We are going to go to the next one, and we're only using positive numbers because look at your sign here. So then we go to 2 and 9, and that is going to give you 11 when you add them. You cannot use that because we're looking for 9 here. The next one you're going to go to is 3 and 6. When you add that, you will get 9. Yes, this is the 9 you're looking for. Since we have 3 and 9 here, and my middle term is 9 here, I'm going to use that 2 factors and write them as 2 sets of binomials. And one is going to be positive, the other one is also going to be positive, and this is going to be your answer. All right, and I always tell my students to box their answer or draw a cloud around their answer. The second scenario that I'm going to give is x squared minus 9x plus 18. Once again, you're going to find the factors of 18 such that when you add them, it's going to give you negative 9. You will notice here that because your C term is positive and your middle term is negative, the factors of your C term are going to be negative. So the factors of 18, such that when you add them, right, and they're all going to be negative, we're going to start out with -1 and -18. That is going to be -19. That is not what I'm looking for. You are going to go to -2 and -9. That is going to be -11. Another factor of positive 18 is going to be -3 and -6. That is going to give you -9. Another key concept that you have to tie into this lesson is that when you are multiplying negative numbers, you are going to get a positive result. So two negative numbers multiplied is going to give you positive, and that is where the positive 18 is, and you end up with two negative factors here. So you are going to circle this set of factors and you're going to use them. You're going to apply them. So you will have x minus 3 and x minus 6 as your answer. Once again, I always tell my students, go ahead and box or draw a cloud around your answer. We are on to the third scenario. We're going to use this format, ax squared minus bx minus c. And I'm going to use, for number 3, x squared. We need a minus b there, so it's going to be minus 3x, and it's going to be minus 18. One thing I must say to you here, your c term is negative. So you have to find two factors such that when added, it's going to give you -3. What this is telling you is that from the factors of -18, the larger factor is going to be negative and the smaller factor is going to be positive. So let's try this with -18 here. So the factors of -18, and in order to get this middle term, which is negative, my larger factor is going to be negative. So I can start out with 1 and -18, and that will give me -17. I'm not looking for -17. I can go to 2 and -9. That is going to give me -7. That is not what I'm looking for. So my next one is 3 and -6, and that is going to give me -3. So then I know that that is the set of factors that I will use to write for my factors here. And I will draw a circle around my factors, and I will write it as x plus 3 and x minus 6. And that is my factor for this one. Now I'm going to move on to the fourth scenario, all right, which is this one. And I'm going to use x squared plus 3x minus 18. Once again, I'm going to find the factors of -18 over here such that when added is going to give me a positive number. Since the c term is -18, the factors of the -18 has to be a positive factor and a negative factor. But when I look at my middle term here, which is 3, I have to say to myself, oh, since this is positive, then the greater of my two factors here for -18 is going to be positive. So I can jump right ahead without further ado, and I can say, all right, so if my bigger number is going to be positive, so I can use -1 and 18, that is going to be 17. No, I'm not looking for 17. Let's try -2 and 9. That is 7. I'm not looking for 7. How about -3 and 6? That is going to give me +3. Now you can use these two factors to write your two sets of binomials. So x minus 3 and x plus 6. And once again, you box your answer or you create a cloud. As an extra icing on the cake, I like to throw in a little bonus for you. And with that being said, I am going to concentrate on these two examples at the bottom here. Say, for instance, I have x squared minus x minus 12. The first thing that you might say to yourself, there's no number in front of the variable in that middle term, right? But guess what? I always tell you about the invisible one. When you don't see a number there, it is considered the invisible one. You can go ahead and factor out this expression. So off the top, we can find the factors of negative 12. You know that 1 is going to be negative and 1 is going to be positive. Because you have a negative 1 here, your greater number is going to be negative. So off the top, you can jump straight to it. In order to get 1, obviously it has to be 3 and negative 4. So those are going to be your factors. So you write them accordingly like this. You have x plus 3 and you have x minus 4. And that is going to be your factor there. For the next one, you will have x squared plus x minus 12. Once again, you have that invisible 1 there. And you will write your invisible 1. You will find the factors again. But concentrate on the middle term. It is a positive 1. The factors of negative 12, you will notice that your positive factor is going to be larger than your negative factor. So you can look off the top and note that the only factors that will give you a positive 1 here is going to be 4 and a negative 3. Or you can write it as negative 3 and 4. It doesn't matter. So you will write your factors as x minus 3 and x plus 4, or you could write it the other way. It doesn't matter, where you have x plus 4 first and then x minus 3 after. Once again, you box your answer, you create that cloud around your answer. And as an extra bonus, I always tell my students, do check your work. So in order to check your work, I'm going to write to check here. I'm going to use this example here. I have x minus 3 and x plus 4 as my answer, and I want to check to see if my answer is correct, because remember now, I want to build that confidence in myself, so when I'm submitting my work and writing this as my answer, I know, yes, this is what it is going to be. Obviously, not every math problem you can double check your answer or go back and use the check method to see if your answer is correct, but please go ahead and use it accordingly when you can. So what you have to do here when you are checking, you are now going to use the distributive property. So you're going to multiply x by x, you will get x to the second power. You will then multiply x times 4, which is going to be 4x. And then you will now multiply negative 3 times x, which will be negative 3x. And you will have negative 3 times negative 4, which is negative 12. You now notice that you have like terms in the middle. You have to combine all your like terms. And when you combine all your like terms, you have 4x minus 3x, which is going to give you 1x. Remember, Miss Winters always tell you, don't write a 1 in front of your x. So even if you find yourself doing this, please go back now and rewrite it without the 1, and you end up with this. You will now notice that this is the same quadratic expression that you started out with. So now you are confident and you said, yes, your answer is correct. Go ahead, write your answer and submit it. With all this concept in mind, I want you to take a step further and go and watch my video on how to factor quadratic expression when a is greater than 1. It is a brilliant video and you will learn a lot from that video. So thank you for watching and see you soon on the other side. Bye now. Cheers.